Here back at AP Review. This is 2015 AB Free Response 2, which is a calculator problem. So we're given an f and g function defined by these equations. I put f in as y1 in my calculator, right? And I put g in as y2 in my calculator. R and S in this terrible version of the graph that is much better on the AP paper. R and S are the areas bounded defined here, right? So we're asked to find, in part A, we're asked to find the sum of the areas between R and S. So an interesting thing here is you can, because you have a calculator, you can actually cheat and not, there's a way to cheat and not find this intersection point A, right? So there's some point here, right, where these guys intersect. So I'm going to call that point of intersection A comma B. I need that point AB. There is a way to cheat around it, but I'm going to need it for a later value. So the very first thing I should do is find these point where these graphs intersect. So I'm zoomed 6, which is the standard window. You can see I'm getting not the best version of this graph. So I would suggest that you zoom in a little and get a slightly better picture of this graph. So I'm going to scroll up to where I can see better what this is doing. And this is the graph that basically you're seeing on your calculator. Or I'm sorry, on the test rather. The graph you're seeing on your calculator is similar to what you're seeing. So there's that shape, right? So I want a second calc intersect for this value in the middle. So second calc intersect, and I'm given, so it landed right where I wanted, which is awesome, right? So I get that this intersection A, right? So I get that f of x equals g of x at x is approximately 1.032831, which I'm going to call A. Right? Now, you may or may not need the y value of this point of intersection. It might be worth having the y. Like, if you want, you could say y is 2.4011081, which you could store as b. The only reason I mention that is every once in a while they'll throw you something where it matters that you know the actual point of intersection. So what I'm going to do is I'm going to quit out of this, so second quit, and I'm going to hit x and hit enter, and that's going to be that value. So I can store that as alpha a, and I'm going to hit alpha y, right, which is also still stored, and hit enter, and I'm going to store that as alpha b, right? The reason I want to rewrite them and store them as a and b is if I do any other second calc intersects, the x and y get overwritten, and I won't have the access to those numbers anymore. Once I label them once as a and b, I can call them a and b for the rest of the problem. So part A asked me to find the area, the sum of the areas from R of R and S. So and we know the other 2 points of intersection. We know they intersect at 0, 2, and at 2, 4. They gave those to us. So in part A, in order to find the area of R, right, I want to integrate. Now, it does matter that you figure out which curve is on top, right? So you should figure out which curve is physically on top. But I'll be honest, if you did it wrong and couldn't tell which curve was on top, so the easiest way to tell which curve's on top, I know this is silly, but you can see the two shapes, right? If you turn one of them off, you can see which curve is which. So if I turn y1 off, now I'm only graphing g. So g is this function. So this is g and this is f. And down here, this is g and this is f. So the nice thing about just turning one of them off is I can see which one's on top. So for area R, it's g on top of f. So I'm going to integrate from 0 to a of the g function, which I can call g of x because they called it g of x, minus f of x with respect to x, plus the area of S is the integral from a to 2, because I want the x coordinates, of f of x minus g of x. And again, I can use the notation the AP uses. So that's what they need to see. And then they don't care how you get, so they don't need this, they don't need you to actually like do the work by hand or show how you put it in a calculator. They want this, and then they want the approximate answer. So so in order to do that, right, I'm going to do math 9, right, math 9, and I want to integrate from 0 to a of g, which was what I called y2. So I'm going to do function y2 minus vars over to function y1, comma, with respect to x from 0. And I didn't mean 0 to 2. I'm sorry, I meant 0 to a. So alpha a, right? Plus, and then I'm going to do math 9 again, right? Vars over to y vars, I want y1 minus vars over to y vars, I want y2, comma, with respect to x from alpha a to 2. Right? So, and then I hit enter and I should get a number. Now you could find each of these separately, or you could just find the entire thing. You're going to get 2.004. Now when I mentioned you could probably do part A without finding this intersection of A and B, it was true. My argument is that if you don't care which one of these is on top, that you could just do one minus the other inside an absolute value and integrate from 0 to 2. So my hypothesis is that I could integrate from 0 to 2, right? of the absolute value of g of x minus f of x, and that should give me the same answer, right? So if I chose to do that, right, if I chose to do that, I would do math 9, right? I'd go to math over to number and pick abs, right? I'd go to vars, and it doesn't actually matter if I do y1 minus y2 or y2 minus y1. I mean, I'll do it in the order I wrote it, but it doesn't matter. So I'll pick y2 minus y1, and the reason it doesn't matter is because of the absolute value, comma, with respect to x from 0 to 2, and I should get the same answer, and we'll see if it pans out, but I feel pretty confident that it will. It's taken a little bit longer because it's harder to integrate things that involve an absolute value, even for your calculator. So again, the AP is looking for this answer, right? The AP is looking for you to do this, right? And you're going to need A at some point later anyway, but an interesting little side note is that if you had done this, it would give you the same answer. It is a little bit of a trick, but it is what it is. All right, cool. Part B. The region S is the base of a solid whose cross-sections perpendicular to the x-axis are squares. Now you need that A. Find the volume of the solid. So now we're looking at region S, which starts at A and ends at B. So what they're saying is there is a square coming off of here. So when we look at part B, the square, right, the side length of the square is going to be top minus bottom, which is f of x minus g of x, which means the area of the square is side squared, or f of x minus g of x whole quantity squared. So the volume, right, my volume then, sorry, we'll switch back to the other marker. My volume is what happens if I integrate from a to 2 of f of x minus g of x quantity squared with respect to x. And again, the AP wants to see that setup, and then they just want you to type to get the answer. So what that's going to look like in my calculator is function integrate in parentheses y1 minus y2 quantity squared with respect to x from a to 2, right? And again, if you had done the shortcut on part A and not found A, you would find yourself in a predicament now. So either way, you're going to have to find that A. So in parentheses, I do vars, I go over to y vars, y1 minus vars over to y vars, y2, close the parentheses, squared, comma, with respect to x from alpha A to 2. And I hit enter, and I should get like a 1.283, and I do. So 1.283. Cool. All right, part C. Let h be the vertical distance between the graphs of f and g in the region S. Find the rate at which h is changing with respect to x when x is 1.8. Okay, so what they're saying in part C is that h of x is the distance from here to here. Essentially, it's the same side length that we just used, right? The difference between f and g. So it's f of x minus g of x, right? They want the rate at which h is changing, right? Well, h changing with respect to x is just h prime of x. So that's f prime of x minus g prime of x, right? They specifically want h prime of 1.8, which is going to be f prime of 1.8 minus g prime of 1.8. And the way I'm going to do that on my calculator is I'm going to do n derive y1 with respect to x at 1.8 minus n derive y2 with respect to x at 1.8. And I'm going to get an answer. Now, you could also have done, or if you want, you could have done n derive y1 minus y2 with respect to x at 1.8, and that would get you the same goal, because that would be the same thing as deriving the difference. So you can either type it twice or you can do it once. It doesn't matter which one. So I'm going to go ahead and do math 8, which is n derive, vars y1 with respect to x at 1.8 minus math 8 vars function y2, comma, with respect to x at 1.8. I'm going to hit enter, and again, it wouldn't have mattered, so I get a negative 3.812 or 3.811, so h prime of 1.8 is approximately a negative 3.811 or 2, right? And they don't ask me to explain that at all, they just ask me to find that value, and that's it.